we're going to spend a lot of time in this class working on trigonometry, sine, cosine, and tangent, like we did in the last video. But part of that is your ability to memorize certain trig values for certain angles. I mentioned this in the homework, and I'm actually going to have you practice it, like I mentioned in the homework, because you need to have them memorized. Speaking from experience, when I was in school, I didn't memorize them, which made it a lot harder for me because I had to try to solve the problem every single time it was asked, as opposed to just knowing it. So I want you to do your best to memorize them, and I wanted to go over a couple of tricks to help you find sine and cosine and tangent for a few specific special angles that we're going to work with a lot. So first off, I want to find sine of theta, or actually I guess we'll just say theta is 45 degrees, cosine of 45 degrees, and tangent of 45 degrees. There are different tricks you can use for this, but for 45-degree angle, well, we'll just draw a triangle. We'll draw our standard right triangle right here. This is my 90-degree angle. If this is my theta, and I say theta is 45 degrees, you all know the sum of the angles of a triangle is 180 degrees. If that's 90, these have to add up to 90. If that's 45, that makes this 45. But now, since two angles are the same, that's an isosceles triangle. And the rule says, if it's an isosceles triangle, the sides that the angle is open to that are equal have to also be equal. Which means this side equals this side. So now, even though I don't know any sides of the triangle, I know that whatever this side is, it has to equal this side. You can actually pick whatever number you want to solve this out, but we'll just call it x, make it as arbitrary as possible. And then this has to be x. So then what's the length of this side? Well, I can just use the Pythagorean theorem. Pythagorean theorem says what? A, which is x squared, plus b, which is x squared, equals c squared. X squared plus x squared is 2x squared. And now I want to solve for c, so I square root both sides, and c is equal to the square root of 2 times x. So this is root 2x. Now I have all three sides of the triangle. The fact that there's an x floating around doesn't matter at all. Now find my trig. Let's see, sine of 45. We said last time sine, SOHCAHTOA, sine is opposite over hypotenuse. So it's x all over root 2x. But then the x's cancel on top and bottom, and it's 1 over root 2. We said last time we don't like radicals in our denominator, so multiply by root 2 on top and bottom. And you get 1 over root 2 times root 2 on top and bottom. And it becomes root 2 over root 2 times root 2 is 2. So this is root 2 over 2. What about cosine of 45 degrees? Well, cosine is adjacent over hypotenuse, but that's x over root 2x, which is the exact same as sine, which means cosine is identical, and it's root 2 over 2. The last thing we want is tan of 45. Tan of 45 is opposite over adjacent. That's x over x, which is just 1. And there we go. Sine of 45 is root 2 over 2. Cosine of 45 is root 2 over 2. Tan of 45 is equal to 1. You are going to want to memorize those, and repeatedly throughout the semester we're going to use them and assume you do have them memorized. Again, if you have a little trouble memorizing them, you can always just draw this picture out and find them yourself. Next, we want to find sine of 30 degrees, sine of 60 degrees, and then cosine of 30 degrees, cosine of 60 degrees, and then tan of 30 degrees, and tan of 60 degrees. And now we have to kind of find a way to draw a triangle to make this work. And the problem is we can't necessarily draw a right triangle and know what the angles, to know that we'll have a right triangle with an angle of 60 and 30 and know what those sides are. without a lot of tricks, but there's something else we actually can do. Instead of drawing a right triangle, we're going to draw an equilateral triangle. I don't draw triangles very well, but assume that one's equilateral. If it's equilateral, that means all sides are the same and all angles are the same. Which means, since the sum of the angles of a triangle is 180 degrees, if all three angles are the same, divide 180 by 3, each angle is 60 degrees. Since it's equilateral, all the sides are the same length, you can call them whatever length you want because they're all the same. To make it as easy on ourselves as possible, we're actually going to call them all 2. It's a nice even number, so that'll work. But now the problem is, these trig ratios are only defined on right triangles, and I don't have a right triangle. But if we remember from our geometry, if you remember things like angle bisectors and perpendicular bisectors and all of that, what we can do is take this angle up top here and bisect it and draw a perpendicular going down. That's now a right angle. This angle was 60, but I bisected it, which means now it's 30 degrees. This is a right angle, and now I have a 30, 60, 90 right triangle. Down on the bottom here, the whole length was 2. Since I bisected this length is now 1. But now I can easily find sine and cosine and tangent of 30 degrees and 60 degrees because I have those angles right here on my right triangle. I just need to find this side right here. For that, we can just go back to our Pythagorean theorem. Let's see. 1 squared plus b squared equals 2 squared. 1 squared is 1 plus b squared equals 2 squared is 4. Subtract the 1, b squared equals 3. Square root both sides, b equals the square root of 3. So now this height is root 3. Now just find my trig ratios. Remember we said last time, your theta, the angle that you're talking about, matters because that determines opposite and adjacent. So make sure you use the right angles here. For sine of 30 degrees, this angle is 30. Sine is SOHCAHTOA, opposite over hypotenuse. So it's 1 over 2. So sine of 30 degrees is 1/2. Sine of 60 degrees, this is 60 degrees. Sine of 60 degrees is opposite root 3 over hypotenuse 2. So it's root 3 over 2. Cosine of 30 degrees, this is 30. Cosine is adjacent over hypotenuse, so it's root 3 over 2. Cosine of 60 degrees, we go back down here. Cosine of 60 is adjacent over hypotenuse, 1 over 2. Tangent of 30 degrees is opposite 1 over adjacent root 3. So it's 1 over root 3. Again, we have to rationalize our denominator, simplify, rationalize the radical. At this point, since we've done it several times, I'm going to assume you can all do this relatively easily. We have a root 3 in the bottom, so we multiply by root 3 on top and bottom. 1 times root 3 is root 3. Root 3 times root 3 is 3. And I get root 3 over 3. Tangent of 60 degrees, this is 60. I get opposite root 3 over adjacent 1. And that's just root 3. And there we go. That's a nice simple trick to help me find sine, cosine, and tangent for 30 degrees and 60 degrees. Again, I stress, you should have these memorized. Start working on memorizing them now. We will use them repeatedly throughout the semester. But if you ever forget, just draw an equilateral triangle, and then you can kind of create it on your own.